day, everyone. So, this is our first discussion. So, we have Ohm's Law. Ohm's Law explains the relationship between the three characteristics of the electrical circuit: the electron flow, the resistance to flow in the wire or other conductor, and the pressure cooled voltage we have in the circuit. So we have the formula I equals to V over R, which is I is the current in amperes and voltage in volts and in resistance in ohms. So we have the voltage, the current, and the resistance. And then we have also, if we are looking for voltage, so voltage equals to current times resistance. And then we have, if we are looking also for resistance of our circuit, we have V over I. So example, if the current in a 330 ohms resistor is 0.015 amperes, the voltage across it is approximately A 5 volts, B 22 volts, C 46 volts, D 60 volts. So we have a current of 0.015 amperes and 333 ohms. So by using the given parameters, we have 330 ohms and the current of 0.05 0.015 amperes. So substitute the value. So we have 4.9 volts or 5 volts. So careful po tayo kasi sa board exam, minsan hindi sila nagra-run off at minsan din po nagra-run off. So you have to round off your answer sa final na. Hindi pwede sa given ka magra-run off. Sa final na po yung answer, tsaka po kayo mag-run off. So next, we have example number 2. An electric fan has a resistance of 100 ohms and is plugged in into a wall outlet. How much current runs through the fan? So we have the given parameters of 100 ohms and then the voltage is 220 volts. So as you observe in the problem, the voltage is not given. So since we are here in the Philippines, so we use 220 volts. Pag wala naman po yung sagot sa choices, you can change that into 230 volts. So depende lang po. So in this problem, I use a 220 volts. So and then we have the resistance of 100 ohms. So our current will be 2.20 amperes. So next example, in Ohm's law experiment, the potential drop across the resistance was a 5 volts and the current was measured as 2.00 amperes. So find the maximum permissible error in the resistance. So we are looking for the resistance given the parameters of 5 volts and then the 2 amperes. So we have R equals to V over I. We have 5 volts divided by 2 amperes. Then we have a maximum permissible error in resistance. We have 2.5 ohms. Next example, the 1 million volts can also be expressed as 1 times 10 to the power of 6 volts. This is a scientific notation. And then we have here the 1.00. So just we have 6 zeros. So we just move the decimal point to have a scientific notation. So we have 1, 2, 3, 4, 5, 6. So we have 1.0 times 10 to the power of 6. Or we have a 1 m volts, 1 megavolts. So example, an electric ion draws a 2.5 amperes to 230 volts. Determine its resistance. So we have the given parameters of 2.5 amperes and then the voltage is 230 volts. So by using the formula R equals to V over I, we have 230 volts divided by 2.5 amperes. So we have the resistance of 92 ohms. So let's go to power. Power is expressed in terms of kilowatt. Kilowatt also is equivalent to 1000 watts, or in megawatt we have 1000 kilowatts, or 1 times 10 to the power of 6 watts. So the electrical power is the product of the voltage and current. So we have also another unit of power. We have horsepower, or HP is another unit of power that is sometimes used. So the 1 horsepower is equivalent to 746 watts. So the electrical energy is also expressed in terms of kilowatt hours. So we have 1 kilowatt is equivalent to 1 kilowatt times 1 hour. So we have 1000 watt hours. So this is the power formula. Power is equals to voltage times current, or equal to V squared, or the voltage squared divided by the resistance of our circuit, or also power is equal to I squared times the resistance. So we have here example. The 3 horsepower is equivalent to blank watts. So since we all know that the 1 horsepower is equivalent to 746 watts, so we just have to multiply it. So 3 horsepower times 746 watts divided by 1 horsepower. So cancel the horsepower. So we have 2238 watts, or 2.38 kilowatts, or 2.238 times 10 to the power of 3 watts. So we have that. So this is the scientific notation. So careful po kayo kasi sa mga choices minsan hindi ganito yung nilalagay nila sa choices. Minsan ganito, minsan din ganito. So dapat ma-master nyo po yung conversion. So we have another example. We have two 500 watts lamps connected in series across a 110 volt line draws 2 amperes. The total power consumed is blank watts. So by using the power formula, the power equals to voltage times the current. So substitute the given parameters. We have 110 volts times 2 amperes. So we have a total power of 220 watts. So we have here how many kilowatt hour are consumed by a 25 60 watt light bulbs burning 5 hours in 120 volts. So, sa problem na to, wag po kayong malito. Ibig sabihin po nito, we have 25 na light bulbs na tag 60 watts. So, we have to solve the kilowatt hour consumed. So, we just multiply the 25 bulbs that we have times the 60 watts times the 5 hours. So we have 7,500 watts, or 7.5 kilowatts. So we have example 7.5 kilowatts is equivalent to blank horsepower. So by using this, we have horsepower equals to kilowatt times 1000 divided by 746 watts. So just substitute the values. 7.5 kilowatts divided by 746. So we have 10 horsepower. Another example, a 100 volt lamp has a hot resistance of 250 ohms. Solve the kilowatt of energy it will consume after 12 hours of using it. So we need to solve the energy. So by using the Ohm's law formula, so we have 100 volts divided by 250 ohms. So our current is 0.4 amperes, and then we need to get the power in order to have energy. So power is equals to I squared times R. So we have 0.4 to the power of 2 times 250 ohms. So we have a power of 40 watts. So since we need to solve the energy that is consumed after 12 hours, so just multiply the 40 watts times 12 hour. So we have 480 watts hour or 0.48 kilowatts. Next, resistances in series. The total resistance of a series circuit is equal to the sum of individual resistances. Applied The voltage applied to a series circuit is equal to the sum of the individual voltage drop. The voltage drop across the resistor in series circuit is directly proportional to the size of the resistor. So what happened when resistance in series? In a series resistor network, the individual resistors add together to give an equivalent resistance, or RT, of the series combination. The resistors in series circuit can be interchanged without affecting the total resistance, the current or power to each resistor or the circuit. So, if we need to find the total resistances, just add the for this circuit, just add the resistance 1, 2, and 3, and so on. So in series, we have equal current for each resistor. So we have here example. So if we are given 48 volts and then the resistance 1, 2, 3, so we have 12 ohms, and then for resistance 2 we have 14 ohms, and then resistance 3 is 13 ohms. So pag ano po, marunong po tayong mag-drawing talaga pag ano, if we need to solve the circuit. So paanda rin po natin yung imagination natin. So, we are looking for the total resistances. So, just add pag series po. So, just add the resistances. So, we have 12 plus 14 plus 13. So, we have 39 ohms. So, from this circuit, the equivalent circuit is we have 48 volts, and then we have a total resistance of 39 ohms. So, we are looking for the current. So, since given ang 48 volts, we have 48 volts divided by 39 ohms. So, the current that is flowing in this circuit is we have 1.3 amperes. So, iisa lang po yung current po pag series. Uniform po sila lahat. Pag 1.23 amperes po ang dumaan dito, yun din po ang dadaan sa resistance 2 and then for resistance 3. Yan po pag series. So next example, a 3 ohms or 6 ohms, 9 ohms, and a 12 ohms resistor are connected in series. The resistor that will consume the most power is blank ohm. So, the answer is 12 ohms. Bakit 12 ohms? Kasi ang 12 ohms is like siya yung magre-resist. So, the more na magre-resist siya sa isang circuit is the more siya magko-consume ng power. So, we have resistances in parallel. So, we have here the circuit. So, you can find the total resistances in the parallel circuit with the following formula. So, we have the formula for the total resistance. We have I equals to R total equals to 1 over R1 plus 1 over R2, and then so on. The resistors in a parallel circuit, the net resistances decreases as more components are added because there are more paths of current to pass through the two resistors have the same potential difference across them. Sa pag-parallel din po is we have the same voltage drop across the components. So we have here example, if a two resistors of 3 ohms and 4 ohms are connected in parallel, what is the resistance of the circuit? So since resistors are connected in parallel, so we have by using the formula, in parallel. So we have 1 over R equals to 1 over R1 plus 1 over R2. So substitute the resistances. We have 3 and 4. So we have a resistance of 1.71 ohms. And another example, three resistors, respectively 11 ohms, 12 ohms, 17 ohms, are connected in parallel. What is the total resistances in the circuit? So we draw the R1, R2, R3. So we have, by using this formula, and then substitute the given parameters, the 11 ohms, 12 ohms, and 17 ohms. So we have a total resistances of 0.233 ohms. So how it looks. So we have here, so the summarize of the resistances for series and the parallel. So we have how it looks. So this is series, the R1, R2, R3. And while the parallel, so ganito po yung parallel, R1, R2, R3. Pag hahanapin po natin yung voltage, so we just have to add the voltage drop across the resistances. So we have the, if we need to find the voltage input, just add the voltage 1 here, voltage 2 here, and voltage 3 here. So just add. And then for current, same lang po yung current. Isa lang po yung dinaanan po pag series. So we have the current, the total current we have to is equivalent to I1, I2, and I3. And the required, the total resistances, add lang din po pag total resistances sa series. If one component is born, current becomes inactive. So, yung disadvantages po ng series, pag may nasirang component po dito, hindi na po gagana yung circuit natin. Kasi wala na po siyang dadaanan. Halimbawa, pag nasira ito, wala nang dadaanan yung current natin. So, hindi na siya magpapatuloy dito. So, magiging open circuit na siya. So, hindi na siya gagana. While pag parallel din po, we have the voltage, the total voltage or the voltage input is equivalent to the voltage 1, voltage 2, voltage 3. So, same lang po lahat yan pag sa parallel. If we need to find the total current, so we just add the total current for I1, for I2, I3. And for the parallel, the reciprocal of the all resistances. So we have that. If one component burns, current stop only through that branch rest. The rest part works fine. So, it means pag may nasisira po dito sa system natin, halimbawa pag dito, so, yung circuit po natin ay gagana pa rin kahit mawala to kasi nakaparallel siya. Pag masira din ito, gagana pa rin yung circuit natin kasi parallel nga. Pag nasira din to, gagana pa rin yung circuit natin kahit wala tong R1. So, that is the difference between the series and parallel circuit. So, move for the current divider. So, we have here the total current and then for I1, I2. And then if we need to find the current I1, so we just multiply the total current of R2 divided by R1 plus R2. If we need to find also the current for the I2, we have I2 is equal to total current times R1 divided by R1 plus R2. So example, two parallel resistors having their values of 50 ohms and 100 ohms are connected in parallel. Find the current flowing through each when the connected source is 20 amperes. So if we have here the 20 amperes, so you need to imagine talaga. Dapat marunong po tayo mag-drawing at mag-imagine para ma-solve po natin yung problem. So if we have connected source of 200 amperes and then the two parallel resistors, we have 50 ohms and then 100 ohms. So we are looking for the current flowing through each when connected in 20 amperes. So we need to find the current of I1 and I2. So by using the formula, and then substitute the values. So we have the total resistances is 333.33 ohms. So just multiply the total resistances divided by the R1, the 50 ohms. So we have then times the connected source of 20 amperes. So we have I1 13.33 amperes. And also for current I2, so just substitute the values. So we have I2 6.66 amperes. Another example, the three parallel resistors have their values of 100 ohms, 500 ohms, and 2000 ohms are connected in parallel. Find the current flowing through each when the connected source is of 10 ohms. So, yun na nga yung sinabi ko, dapat mag-drawing muna tayo bago natin isolve yung problem. So, ilagay po natin yung mga values. We have 100 ohms, 500 ohms, 2000 ohms. So, first, we need to find the total resistances. We have 80 ohms. And then, substitute the values. So, for I1, we have 8 amperes. And for I2, we have 1.6 amperes. And then, for I3, this is I3, we have 0.4 amperes. So let's go to voltage divider rule. So the voltage drop across a series resistor is directly proportional to its magnitude. The voltage divider rule lets you calculate the voltage drop across a resistor that is connected in series to the other resistors. So, why we have voltage divider and current divider? Minsan kasi kulang yung mga yung binibigay nila na parameters. So, we cannot use the ohms though, we cannot use other formula. So, we have the voltage divider and the current divider. So, we can have the what we are looking for. So, this is for voltage divider. So, V1 is equal to R1 divided by R1 plus R2 times the voltage input. And then the voltage 2 is equal to R2 over R1 plus R2 times the voltage input. So, just keep on solving para ma-memorize nyo po yung formula. So we have example here. Consider a series circuit containing two resistors of 5 and 10 ohms. The input voltage source is 12 volts DC battery. Now, to find the voltage across both resistors, we need to apply the voltage divider formula for each. So, minsan sa problem, hindi po nila minimension yung voltage divider. So, mabuti talaga na magdo-drawing muna kayo para mas maintindihan niyo yung circuit problem. And then we have here for V1 we have the resistance of 5 ohms, and then for R2 we have 10 ohms. So we need to find the voltage across the both resistors. So just use the formula for V1 and V2 and then substitute the values. So we have voltage 1 is equivalent to 4 volts, and then for voltage 2 we have 8 volts. So another example, the two resistors of a value of 1 kilo ohms and 4 kilo ohms are connected in series across a constant voltage source of 150 volts. Find the PD or potential drop across the 4 kilo ohms resistors. So, careful din po kayo kasi minsan PD yung nilalagay nila. So, it means potential drop. And then, it means also the voltage drop. So, same lang po yun. Yun lang po yung ginagamit nila pang lito po natin. So, by using the formula, so we have 150 times 4,000 ohms divided by 1,000 ohms plus 4,000 ohms. So, the voltage across the V2 is we have 120 volts. So, transformer. So, we have here the transformer. So, this is our primary. And then we have our secondary. So, in the formula, the turns ratio of transformer is equivalent to the number of turns in primary divided by the number of turns in secondary. And also, the turns ratio is equivalent to the voltage of the primary divided by the voltage of secondary. And we have also that the turns ratio of the transformer is equivalent to the secondary current divided by the primary current. So example, if the primary winding of a 10 to 1 step down transformer has 20 turns, the secondary winding should have a blank turns. So the turns ratio is equal to N1 divided by N2. So substitute since it is mentioned here that 10 is to 1. So we have 10 divided by 1 is equal to the 20 turns for the um, primary, and then we're looking for the secondary winding. So our secondary winding is 2000 turns. In the transformer, the primary has 500 turns and the secondary has 50 turns. So 100 volts are applied to the primary coil and the voltage developed in the secondary will A 1 volt, B 10 volts, C 1000 volts, D 10,000 volts. So what's your answer? So given the primary coil has 500 turns and the secondary coil has 50 turns. So it means 500 is to 50. Then the voltage applied to the primary coil is 100 volts. So that is the given parameter. To find the voltage developed in the secondary coil, we have the relation between the voltage and the number of turns of primary and the secondary coils. So the primary voltage divided by the secondary voltage is equal to the primary turns divided by the secondary turns. So just substitute the value. So we have the secondary voltage of 10 volts. So therefore, the option B is correct. So that is 10 volts. B, 10 volts. So another example, a step-up transformer has turn ratio of 10 is to 1. A cell of EMF is electromotive force or voltage. The 2 volts is feed to the primary. The secondary voltage developed is A, 20 volts, B, 10 volts, C, 2 volts, D, 0. So the transformer works only in EC input. Here, cell is providing DC input, so the voltage produced in the secondary coil is 0. So the option is D. So, careful din po tayo pag ganitong problem. 'Di ba sabi niya na may turns ratio na 10 is to 1. Pero, ang ginagamit niya po ay baterya. Mag-feed po siya ng 2 volts sa primary. So, ano po yung madedevelop daw sa ano po yung secondary voltage? Pero wala po siyang madedevelop since baterya po yung gamit niya. So, kaya po we have the answer of D. So, yung transformer ay gagana lang po sa AC. When the turns ratio of a step-up transformer is 20 and the primary AC voltage is 12 volts, the secondary voltage is A, 12 volts, B, 120 volts, C, 240 volts, D, 2,400 volts. So the answer is letter C. When the transformer designed to increase the voltage from primary to secondary, it is called step-up transformer. And when it's designed to reduce voltage from primary to secondary, it is called step-down transformer. So halimbawa, if we have a 10 is to 1, so that is step down. Pag step up naman po is 1 is to 10. So pinapataas po yung voltahe natin. So if we are for the step up transformer turns ratio, so we have the secondary voltage divided by the primary voltage. So we have 20. So we have the secondary voltage of 240 volts. And for the step down turns ratio, so the primary voltage divided by the secondary voltage, so we have 0.6 volts. So the answer is option C. So the secondary voltage is 240 volts. So the input AC voltage to the transformer is 3 kilovolts and the output is 100 volts. Then A, the ratio of the number of turns in the primary to the secondary coil is 30 is to 1. B, the transformer is a step-down transformer. C, the transformer is step-up transformer. D, both A and B. So what is your answer? So given the voltage across the primary windings, we have 3 kilovolts or the 3000 volts. And for the secondary winding, we have 100 volts. So here it is as to find out the ratio of the number of turns in the primary coil to the secondary coil. So we have N1 divided by N2 is equal to V1 divided by V2. So then substitute. So the turns ratio is 3000 divided by 100. So we have a turns ratio of 30 is to 1. So the ratio of the number of turns in the primary coil is 30 is to 1. Since the input voltage of the transformer is 3 kV and the output is 100 volts, it is a step-down transformer. So have you observed, di ba? Sa primary, ano niya, is 30. So it means mataas. But sa secondary winding niya is 1. So it means step-down transformer. So our answer is letter D, both A and B. Since A is the ratio of the number of turns in the primary to the secondary coil is 30 is to 1. And then B, it is a step-down transformer. So thank you po sa pakikinig. Thank you. Thank you and God bless.